So we're in 8.4 for a lesson with the longest title in history, using substitution to solve equations that are in quadratic form. So all chapter we've been talking about quadratic equations. Quadratic equations just means you have an x squared, you have an x, you have a number. What's happening today is things are getting a little bit bigger. And instead of just x squareds and x's and numbers, you've got some stuff getting squared. And you've got some stuff, and you've got a number. For example, this is in quadratic form. This has some stuff. If you square x squared, that's x to the fourth. So it's called in quadratic form because this is the square of that. If I keep walking leftward, this is the square of that stuff. If I keep headed more to my left, your right, this squared makes this. Or on this last problem, the root of x squared makes that. These problems are all set up so they don't just have x's and x squareds and numbers. They have some other stuff that's just bigger to look at. So there's a technique in math called substitution that often you use when you're like comfortable with the shape of something, sort of, but you just don't like how it looks. It looks bigger than you want it to look. I think we could all agree, especially that second one that had all the parentheses. That's bigger than you really want the thing to look. That makes you uncomfortable. So substitution is just a way you can change how something looks without really changing what it is at heart. For whatever reason, and I have no idea why, the official variable for doing this is the letter U. And that's the letter I'm going to use. That's usually the letter that gets used when you do a substitution process. So what we're going to look to do, first step is let U equal whatever stuff I was pointing out in the middle. That medium-sized variable part, whatever that might be. So if I stroll through this, if I have to pick between x to the fourth or x squared, I'm going to pick x squared to be my u. That's like the medium-sized thing. If the book is kind to you, they'll always put it in descending order. Biggest, medium, nothing. If they do that, it's always in the middle. If they mess with the order, you might have to put it in descending order, but there's always a big power, a medium power, and a just plain number today. So if I go to this, there's biggest stuff, medium stuff, and just a number. So the U is going to be that medium-sized set of parentheses. You don't have to write the parentheses. They wouldn't kill you if you did. If I stroll to this one, that's the biggest power, that's the medium power, that's the plain number. So I let U be that medium variable thing. And for this, x is bigger than the root of x. The root x is the medium-sized kind of thing. That's going to be your first move is just let U equal that middle thing. When you do that, you're going to now have an exchange of some stuff. The plus 3 is still here, the minus 10, the equals 0. None of the numbers are changing. We're not looking at any of these numbers. So as I stroll from right to left, this still has the 0, the equals, the negative 10, the minus 3. This still has the 0, the equals, the 24, the minus 14. None of that's changing. This still has the 0, the equals, the 9, the plus, the minus 10. None of the coefficients change. None of the numbers change. The only thing that we're changing is all those variable portions. And what should happen now, we should be looking at the U that we picked is now in the middle, and the beginning part is having a U squared. There should be a U squared, a U, and a number instead of how it used to look. We called this U. And this is the square of what we called U. So it's the same exact problem with the same exact coefficients, just instead of the variables that made us a little less comfortable, we got U squareds, U's, and numbers. This, likewise, is going to have U squareds, U's, and numbers. This we called U, so I just changed its title. This is the same stuff that I called U, it's just squared, so I switched it. And that's going to happen all throughout these problems. This is just going to be U squared, U, a number. This is going to be U squared, U, a number. Because all the problems at their heart, they had some middle variable thing that I called U, so I just switch it. And the beginning part of the problem was the square of what was in the middle. So that's the way these look. At that point, we're ready to go. I'll go back this way, we'll look at the notes again. We just accomplished step one. Step one is we did a substitution, we let u equal that middle stuff, and then we got u squared using numbers. What we're now looking to do is solve for the u. Okay, so what that means is if we can factor, we will. We've been factoring equations that look like these for years, since back to Algebra 1, which was like 8th, 9th, 10th grade, whatever grade you hit that. But we can factor and get answers out of those. A couple days ago we learned the quadratic formula. I think there's 2 in the homework that you have to use the quadratic formula because they won't factor. But if you can factor, that is the preferred way to go. So if we go to factor this, and if you're watching the video on your own somewhere, someplace, you might want to just pause the video and try to factor all 4 of these yourself and then unpause and see if you can do it. But if I factor this, it's going to go u minus 9, u minus 1. And that would tell me that the u could equal 9. It would also tell me that the u could equal 1, because the solutions are always the opposite signs of the factor. But we're going to just proceed through all these problems and do that in the middle here. Factor, get answers. So this, I go use minuses because that's a plus, they have to be the same as this, 12 and 2. This piece tells us u is 12. This piece tells us that u is 2. Keep on strolling. Factors, u and u. With the minus, I go different signs. This will hog the bigger number, so 5 versus 2. This u would be a negative 2. This u would be a 5. And if I go to attack this, it's almost the same, the signs are a little different. This is a plus 5 versus a minus 2. This gives a negative 5. That gives a positive 2. So we can take a stroll back to look at the notes or what was over there. We just accomplished step 2. We factored, we got our solutions. We're almost finished. What we're now going to do in step 3 is get ourselves back more to where we came from. For a second, we stepped away from the variables we had, made the problem simpler, made it a problem like an Algebra 1 problem, did it. But now we've got to get back where we came from. So the way we get back where we came from is we let the u that we picked in the very beginning in step 1. We let that equal the answers we just got in step 2. And then we're going to solve and we're going to check. So I'm going to make a switch back. I'll use my eraser here to, I'll cross it out so you can see what used to be there. U was not what we really wanted at the beginning of this process. What we really wanted was x squared. U, again, is not what we really were after. U is really another name for x squared. We're going to replace these u's with the stuff that it really means, and then we're going to try to solve. If we have squaring, we do the opposite. The square root of 9 is both 3 and negative 3. We want those answers. This, if we do a square root, we get a 1, we get a negative 1, we want both of those answers. It's usually smart to check. If it's an odd, it's in the back of the book. If you're a teacher, you did this problem before, and I will tell you all 4 of those answers will work, and we want 4 answers. If it's an even, or it's a quiz, or it's a test, maybe you plug it in and check it to see what happens, but those 4 are winners. So again, step back over here, we're in the same spot. Okay, the u's are not what we wanted permanently. The u is really just a switch out for x squared minus x. So we're going to switch back in x squared minus x. And then we're going to just go flash back to how do we solve this way. If x squared minus x equals 12, how you solve that is you get the problem equals 0, and you try to factor. How we'd solve this is we'd get that equals 0. And we would try to factor. This would go xx minus 4 plus 3. This would go xx minus 2 plus 1. This would get me 4. This would get me negative 3, 2, negative 1. Got 4 answers again. They're not all going to have 4 answers. Sometimes the answers don't work, sometimes they do, sometimes there's one, sometimes there's two, sometimes there's three, you don't know. It's on my paper, so I take a little peek. All four of those are valid answers for this one. If you don't believe me, plug them in, they'll work. If I go to this one, again, the u's have to get replaced by what u really means. U really means t to the 1/3. Maybe people aren't comfortable with t to the 1/3, so have a discussion quickly here with each other. What fraction powers meant last chapter were roots. The bottom was the index, the top was a power. What this really means is this. And you might feel more comfortable with that, so I'm going to use that. I'm going to go cube root of t, cube root of 2. And then we do some opposites. To get rid of cube rooting, you cube. So -2 times -2 times -2 would be -8. Then on this one, 5 times 5 times 5 is 125. If it's an odd, look it up. If you're a teacher with a paper, look it up. I agree with that. These are both valid answers. If this were a test, I might plug them in and see if they would work. Last one, but same move. We replace those u's with what the u was chosen to mean. It was chosen to mean root x. Root x. To undo square rooting, you square. So if we square this, we come out with 4. If you squared this, you'd come out with 25, but we've already missed a detail. We'll double back and talk about it. But if we got a 25, that's not going to work. Okay? Even though squaring gets erased by, or square rooting gets erased by squaring, -5 times -5 is 25. That's true. If we went here, 25, adding some more stuff, and subtracting 10, there's no way that makes 0. That is not going to happen. So there's a loophole here. You might have forgotten, you might remember back from chapter 7, anytime this symbol is used, this symbol has to equal positive numbers only. When a person says, what's the square root? It can go positive or negative. Over there a minute ago I did that. We'll scroll and look at that. Here we had squaring, so I started talking about doing square roots. I got 2 square roots, a positive and a negative version, and that's okay. If square rooting is a process you encounter, it's a word that a teacher says, you get double answers. But when you start to specifically see this symbol means positive square roots only. So if this symbol equals a negative, that is a dead-end road. That is not going to give you any answers. That is not possible. We've encountered things like that before. Like if I said to you the absolute value of a number was -10. That's a dead end. Okay? You can't have absolute value symbols causing negative results to happen. That's just not a thing. This symbol cannot cause negative answers to happen. That's not a thing. This is a dead end road. We ditch that. The only answer for this one is 4. So I believe the only way that some of the answers get eliminated is because of this rule. Any even index, like if this were a 4, we still couldn't do it. But if you have any even index radical causing a negative, that is going to be a throwaway. Even index radicals equaling positives will produce answers. I don't think there's like a severe need to check all of these answers because most of them are going to work. But just be on the lookout for that radical with even index equaling a negative. That's going to cause some disappearing acts. But it's always a good idea to check. It's just difficult to convince teenagers of that. But that's what we have going. The homework here is going to be on page 364. Page 364 is going from 1 to 18. Like I said, I believe almost all of them are going to factor at this step where I factored. All 4 of these on the board I factored toward the middle of the problem. I think there's 1 or 2 in the homework that you'll get stuck doing the quadratic formula because it's just how that works sometimes, so be ready for that. In terms of future events, tomorrow would be 364, 1 to 18. We would talk about how to do it, maybe do another sample or a reteach if necessary. There's a sheet that would be 2 days away, and the chapter's over. That's all we do from chapter 8. So chapter 8 is gone for us. If you don't yet know the quadratic formula, you need to memorize that. If you're not sure, quick pause the video and see if you can write it down. But it's -b plus minus root b squared minus 4ac all on top of 2a. And yesterday, for a little bit of the homework, we focused on the discriminant, which was this part of the formula mattered for yesterday's homework a good bit. But you need to know that. But coming up soon, we'll do a review of this 364 homework. We'll do a review with the worksheet, and test is 3 days out, and then chapter 8 is a goner. That's all I got.